All right. So you got your lab handout. This is going to be your lab handout. You will share data with you and your partner, but everybody turns this in individually. So if you look on the directions, there's a few slight changes. Like instead of a glass, what's it called? A glass tube. We're going to use these plastic PVC pipes that are cut, and you're going to have to make your own deal here. You're going to need the string, and then this rubber stopper is tied to one end of the string, and then you're going to need a loop in the other end to hang a mass on it. So you guys will have a set of these masses, and so it hangs like this. So if I were to just hold it like this, and you guys can assume that this is a lot lighter than this is, what's going to happen?
Your rubber stopper.
Rubber stopper is going to go up, and the weight's going to go down. In the same way, if I were to hold it this way, right, it just wouldn't work. But there is a way that I can keep this in suspension right here, and that way is to twirl it around and keep tension on it. So what happens if I swing it too fast? What's going to happen? It's going to rise up. Oh, if I don't hit something first. I think I've caught it on the screen. So I get for having jumped all over this classroom. Yeah. If I do it too slow, let me get somewhere over. If I do it too slow, then it doesn't give enough tension to hold it up. So there is a point that it's just right, and at that point, that is kind of what you're looking for. All right. So it's going to take some practice to kind of figure this out. So the faster, you don't want it to go down, you don't want it to rise up, you just want it at that sweet spot. And so we're going to do with this, we're going to do three different tests. We are going to look at how the radius affects this holding the weight, which is the centripetal force, right? So we're going to see how the radius affects the centripetal force. We're going to see how this hanging mass affects the centripetal force when we'll test the velocity, how fast it's spinning around. And then we're going to test how the mass of the stopper, this thing swinging around and around and around, affects the centripetal force. To do that, you've got your directions for it on your handouts. There's a couple of things, though, that we're going to need to kind of discuss before you go out there so you kind of know what's going on. The first thing is, what is the radius and all that? Where do you measure? Well, if I'm slinging this thing around and around in a circle, the radius of my circle is the length of the string that's going around and around in a circle. So I could just measure that, and that would be my radius. So if I've drawn it here, here's the plastic pipe, and here's the string that goes through the plastic pipe. Right here is my radius. And you can just measure from, right at the middle of the stopper somewhere to where it goes into the pipe. So that's going to be the radius. Hanging mass will be hanging here, and you can get the weight of that it's stamped on the masses. The stoppers, though, don't have any kind of mass on it. So you'll have to come in the classroom and put those on a scale and weigh them. Sometimes we're going to add masses. So this one's stuck there, right? If I wanted to add another rubber stopper, it's almost kind of like if anybody fishes, it's like you're stringing a fish. You get that first one in there, and then the rest of them, all you got to do is, you don't really have to tie anything on. you might need to, they're all new strings too. So you just pull it through and it's on there too. So you'll do 2 of these and then 3 of these, and I think up to 4 of them. So now it's double the mass on the end of the string. Problem is going to be when we do this equation right here, FCM stopper times V square over R to get the force. How do we find the time it takes for this thing to go around one time? So if I'm doing this, measure the time it takes for it to go around one time.
What?
Are you going to get very accurate results?
No.
No. So a more accurate way is I can count how many times it's going around. 1, 2, 3, 4, 5, 6, 7, 8. So if you count 20 times, right? 20 revolutions, and it takes 10 seconds to do that. So 20 revolutions in 10 seconds, you say 10 divided by 20 is 0.5 seconds per revolution. Does everybody understand that? So you can choose to do 10 revolutions, you can choose to do 20, but you need to count. So slower, 1, 2, 3, 4, 5, 6, 7, and then you could count however many you want. And somebody's doing the stopwatch, and when you get to that number, that designated number, you stop the stopwatch and put the time over the number of times you counted around, and that's the time that you're going to use in your equation to get your tangential velocity. And all this is on a table somewhere too. Once you get your tangential velocity, then you can calculate the force by mv squared over r, because you'll know the mass of the stopper, you know the speed, and you know the radius because you'll measure it. So what you're going to need, what everybody's going to need are 4 of these stoppers, 4 of these rubber stoppers, some string that you can cut or I can cut. You'll need a piece of pipe. You'll need a stopwatch of some sort. iPhone works. And then you'll need a meter stick, which I'll go grab. You will also need to go into Mr. Marble's class and grab a case of these weights. Grab the ones that say grams and not newtons. And if there's not enough, we'll just have to share. That'll just cause us to not have to convert newtons into grams.
Yeah, exactly.
Does anybody have any questions about what we're doing? Most important thing right now is to get good data. And once you get the good data, we can come back and we can talk about exactly how to analyze it and what all that analysis is going to mean. But real important, if you do the first test where you change your Hagen mass, so if you look on your data tables here. The first one I said change Hagen mass for your first 4 trials. So you'll have 4 different Hagen masses. You'll start off with a 100 grams, and then you can go to 150 grams and 200 grams, and you can go to 50 grams. You're not going to be able to do it with 1,000 grams. It's too heavy. You won't be able to get it going fast enough. So stay kind of right in the middle. But when you do that, when you change your mass, every time you change your mass for this first test right here, you keep everything else the same. So you keep the radius the same. Okay? You're not going to change anything about the radius. When you change the radius, you keep the mass the same. So you don't change the mass. When you change the mass of the stoppers, you keep the radius the same, right? And so when we do a test, you only change one variable, right? Otherwise, the test is not valid. Okay, so make sure that you're keeping stuff constant other than the one thing that you're changing. And it calls it out right here. on the side of the tables. Okay. You can start by reading the directions and making sure that you understand that. And then come grab your stuff, and then we can go outside so we don't knock each other's in the noggin. Okay.
If it's too cold, we go back in.
No.
No. Better bundle up.